This is the third part of our meeting. It's way over 80 minutes now. We discussed in detail about the schedule that I'm going to follow. Right now, I think you are away. You know what's going on. Please, if you have friends who did not come to these sessions, ask them to watch the video instead of sending me an email and asking the same questions over and over again. Please tell them to watch these videos or the decisions we have taken. Once again, in the group chat, I'm sharing support registration. So those who have issues about SIS, this is where you should contact about your registration problems. Okay. So in today's topic, we only have like 2 different chapters left now to the end of the course. Today's topic is functions. The functions, also called methods, they are the building blocks of a structured programming environment. What is a structured programming environment? Basically, the programs that we write that follow a top-to-down model in terms of putting up the programs from the model that they run sequentially is called a structured programming model. But this is not the only way to construct your programs. Basically, you can create a method in between these sequences and allow your program to jump from one point into another. And that way, a certain functionality in your program can be divided. It could be handled there inside that specific method. And then it can go back to wherever it left off and continue the program. This is the core idea behind methods, to divide programs into segments so that you can basically deal with the program in small segments rather than keeping it all together. If you are writing a computer program that is very small, it's not a big problem. You can simply use, everything in the main function, and you don't have to use methods if the program is small. However, not every program that we use is small. As a matter of fact, majority of the programs that we use today are very big programs that include hundreds of lines, if not thousands. This means that in order to keep the program all together, we cannot type everything inside the main, but rather we try to divide the program into small segments, such as a calculation is in a function, another calculation is in another function, and so forth. So basically, a function, also called methods, is an effective approach to divide the program into segments. Okay, that is the purpose of it. In C, the function construction is used to implement this model or method of programming, and it is the structured way to divide the programs into segments. So what you can do with function is that you can basically divide the program and manage it. That is the big part of it. You can reuse these specific features should you want to, because as you divide the program into segments now, it is possible for you to reuse them. As you divide the functions, it is possible to reuse those functions, as you call them. And finally, you only write it once, but you can use it as many times as you like. That is the core idea about functions. All console programs contain the main functions. This is the funny part about functions, is that you already know how a function works because you have been using the main function. The main is a method, the default method in the program, as you can see. And when the program runs, that is the method that runs. So whenever you run a program on your computer, let's say function here, whenever you run the computer, the entry, which is the black screen that is created, as you can see in here, is actually created through the main function. Writing the main has a specific standard. As you can see, you can write integer main. You can write the void main if you want, but then you wouldn't have to, you shouldn't have return zero at the end because then it is expecting for you to return a value. Okay. The main function is a specific function that is written in that specific style. So in order to use the main, you need to make sure that it includes integer and return zero. That is kind of like a rule. But as a matter of fact, you can create your own functions. You don't have to follow this pattern, and you can create your own functions. In C++, you have two different functions that you can use, two different types. One of them is called predefined functions, the library functions, such as like the main one. The main already exists in the library. All you are doing is to use that specific function because it means something already. It has a very predefined role. This could also be the math library functions or standard library functions. The second category is the user-defined functions. So this means that you can use your own functions. Instead of relying on the library ones, you can actually create your own functions to do stuff. So this is the first one, which is the predefined one. That means they already exist in the C and C++ library, like the main. And this is the second one, which means you can write it on your own, should you want to. So these, they do not exist, but you can use them to basically create your own functions. Today, we're going to spend some time, a little bit, on the predefined functions, and in the next lecture, I will continue to discuss more of the functions. In the predefined functions, we know that these exist already in the library, and all we need to do is to call the function itself. It already has a specific standard. It already has a specific, pattern that you gotta use, and all you have to do is to call it. Usually, these are mathematical functions. They do not have any other job other than completing a specific mathematical equation or problem. They are also defined, most of them, under C math, although there could be other standard library functions. The ones that we're going to use in this course are mostly defined under math library. And all you have to do is to call this specific library in the program, just like you include IOStream at the top. All you have to do is to put include CMath in here, and then you can use the function. Whenever you include a function, you must make sure that you put the specific library. So if I don't put the library here, for example, and type the rest of the code, some of these codes might not be recognized, as you can see, by the compiler, because the compiler then wouldn't know where this statement is coming from. By putting the library there, you are basically telling the compiler that I am taking this specific statement under this library, okay, so that it can recognize it. Basically, this is the house of this specific statement. So whenever you use a statement, you must make sure to reference their house. Okay. The same thing also happens for other predefined functions. So for the functions that we're going to use, their house is CMath. And majority of them, almost all of them actually, will return a double value. So it's not going to be an integer, it should be a double value. This is a full list of the functions that we're going to use in this course. Please don't get scared. You don't have to memorize this list, but you need to understand each and every one of them, what they do. And they are mathematical equations. So if you know math, you already know majority of these functions anyway. So let's have a look at them one by one. The first one is the square root. And as you can see in the square root, it accepts a specific variable. What it does is that it finds the square root of that variable. So you do not need to calculate these, but what you need to know in here is how to use these specific functions. For example, I will not ask you what is the square root of 900, but what I'm going to ask you is that in order to find the square root of 900, which of the functions should I need to use? A, exponential, B, logarithm, C, floor, D, square root. Then you will know square root is the one that you need to use. Okay, so you just need to know which function does what, and that's the only thing you need to know. Remember that most mathematical equations will return you a double value. So that's why everything in here represented, as you can see, with decimal points. The next one is exponential. Exponential is basically the inverse of the logarithm, particularly natural logarithm. And if you actually look at the numbers, you will see that it's completely the inverse. An exponential is represented as e dot x, which x is the value that you want to find the exponential. So if you want to find the exponential of 1, it's 2.71. And if you actually look at the logarithm, it's the opposite. So the logarithm of 2.71 is actually 1, which is the complete inverse of the exponential. Can you see that? So exponential and logarithm, they are opposite of one another. And they are used in a similar fashion. You can see it from the function definition that in order to use an exponential, you need to type exp, and in order to use logarithm, you need to type log. That is the rule of it. Underneath, you will find logarithm of base 2. This is the one that we use in math quite often. Instead of, using the real logarithm, the natural one, you can sometimes use the base 10 logarithm to ease the process. And that is quite straightforward. It just counts the number of zeros. Like look at in here. In here you have 0. Underneath you have the decimal digit 1. You have the decimal digit 2. If this was 1,000, it will be 3, and so forth. So basically the number of decimal will give you the logarithm base of 10. Next we have fabs, which is the absolute value, such as you put absolute sign here, you put x in there, and that will give you the absolute value, such as the absolute value of minus 5 is 5, and that is the fabs equation. You can see it in here, absolute value of 5 minus 5, underneath it, sorry, absolute value of minus 5 is actually 5. Next, we have seal. Now, seal and floor are very, very similar to one another with one difference. One of them rounds down, the other one rounds up. Seal refers to ceiling, which means round up. And floor refers to the floor that we step on, which means round down. Whenever you put a value into the seal, it will always round it up. Even though it is less than 0.5, you will always see that it will be rounded up. For example, seal 9.2 is actually 10 because it rounded up. The same also goes for minus 9.8, which is rounded up again. Remember that for minus numbers, the closer to 0, the bigger the number is. The same goes for floor. With the floor, what you need to do is that you round it down this time. 9.2 this time becomes 9, and minus 9.8 becomes minus 10. Moving on, we have next power, x raised to the power of y, such as when you want to calculate the power of 2, the 2 raised to the power of 3, if you want to calculate it, you can use this function, and it will generate you the outcome of 8 in terms of double. Remember that the outcome here will be a double value. Okay, so if you try to initialize to integer, you might actually get some error or not show the full value. So make sure that you basically use a double value within these functions. The next one is called fmod, which is basically the same as finding the mode. Previously, when you wanted to find the mode, we just type a number. We put this equation, if you remember, and we put the number itself, and we said that this is, let's say, 1. It means that 5 divided by 2, remainder is 1. You can also achieve this through ffmod. So in order to do the same operation, what you need to do is you just type fmod here, and inside the bracket, you just type whatever numbers you have. In this case, 5 and 2. And just like with the other functions, this will return you a decimal number, because not always the number that you are supposed to find is a natural number. Okay. The final ones, which are the least used ones, are sine, cosine, and tangent. I don't use these ones that often, but they are very straightforward anyway. You just need to type sine, cosine, and tangent, such as sine 0 is 0, cosine 0 is 1, tangent 0 is 0. Right now, you need to understand that this is not a math course, so I'm not going to ask you to find sine 90 and show me it, but rather I will give you an equation in terms of math and ask you how this can be converted into a mathematical format. Okay? That is the only questions that you can actually see in this kind of scenario. So basically, I can write an equation for you, such as like this: square root of x plus exponential 2 plus x to the raised to the power of 5. If x is 1, let's make x is 4 actually. If x is 4 and y is 3, what will be the equation? To solve a question like this, you must make sure that you type this specific statement in terms of programming code. That is the equation. Okay? So how do you do this? You go back to the program itself, and you're going to take up the values. You can take up these values if you want by basically coming here, ask the user, or initialize. I can say that x and y, now these values are given to me, x is 4, y is 2, and create the equation. The value is double, so I'm going to put the result in here, and the result will be square root of x. Now, as soon as I put the square root in here, if I try to run this program, it will generate me an error. The reason is I didn't put the include IOStream statement. That is the only reason why I will see this. So if I try to run it, you'll see that this part is not recognized. If I come here, however, and put up the necessary include for the math statement, which is include the math, then it will start to recognize this, because this specific function is actually inside this library. So now I can run this thing and it will generate me an outcome. Right now, there's nothing to show, so it runs, but it doesn't show anything. So what we're going to do is to basically complete this equation. If you see in the equation part, you see we have square root plus exponential 2 plus x raised to the power of 5. So I'm going to complete it. We have exponential 2 plus O
which is x and y. That is the equation, and the values are already there. The final thing I'm going to do is to show the result. You can just leave a blank space and show the. So when these values are being given, you see that now, oops, we forgot the plus sign here. When these values are given, you can see now that these can be calculated on a computer environment, and it can actually generate the results. So any kind of formula that you already have in mathematics, in engineering, or in other areas, as you can see, can be converted to the source code. So you can find the code of it using C++ programming code. The functions are not only for this purpose. Of course, we have other functions that can help you to build up other stuff. But as this course is more about introductory level, this is where most of our functions will be used. The idea here is not to do the calculation, but to learn how to use predefined functions. In order to use a predefined function, you must make sure the library exists there and you have an equation to evaluate it. Do you have any questions? Is this clear? Can you please respond to group chat if you have any questions? I'm ready to listen to you. Hello, is anyone there listening?
Yes, sir. Clear.
Did you understand how this works?
Yeah. Yeah, it's clear.
Very straightforward anyway. So you can see from there. If you want to use the specific functionality, all you have to basically to put the include statement up there and use it down here. Okay. This is basically predefined functions, and there is also another function called rand, which will allow you to find a random number within range. Now there are many different ways to find a random number within range, and the uses for this is to reflect a luck scenario, such as if you're going to build up a game, let's say that are displaced with dice, you can basically reflect that experience using standard library functions. The round basically generates a random number in between 0 and the integer range, which is 32,000 something. But you don't actually have to limit it within that range. You can basically define your own range when you want to generate a random number. So for example, if you want to generate a specific number in between 1 and 6, you can do that using the round functionality, such as a dice operation. So if I want to throw two dice, I can define them as dice 1 and dice 2. In order to use the run function, we use another library called C standard library and C time. These two libraries will allow you to define them. So C standard, C time. The standard library includes the run function, and C time make sure that each time you have a different random number. To make sure that the numbers are random in each time, you type as round and time null. This nullifies the time element so that each time that you have to throw a dice, it actually is a different number. Okay, that is the purpose of it. Each time you throw a dice, it is actually a different number. To do this now, we're going to use a percentage plus number plus 1. So that is the range that we want to achieve. In this case, we want the number to be within range. If you actually generate a random number between 0 and 20, for example, you just type 20. But technically, the lowest number when you throw a dice is not 0, it's 1. So we're going to put 1 in here. So in case this is 0, the number is 0, it's going to be like, you know, it's going to be 1. The lowest scenario that you can see, it's going to be 1. Alternatively, you can use a formula to show the max and the mean value. So if you want to, for example, get a number between 1 and 6, what you need to do is to put the max value to 6 and 1 to the mean value. So what you have in here is that 6 minus 1 plus 1 plus 1. These will go right over there. It will go. So inside you will have 6 round plus 1. So if I want to generate a specific scenario to basically imitate a dice in my program, all I have to do is to put there the value as round. So this is going to be dice 1 round percentage 6 plus 1, and dice 2 is going to be the same, round percentage 6 plus 1. Just like in backgammon. Do you know what a backgammon is? So if you don't know, I'm gonna show you what a backgammon game is. This is backgammon. I'm sure you have played this game sometime in your life, and if you actually look at the game itself, it is played with dice, and it has the dice is basically has 6 sides, right? And the lowest number you can get from the backgammon from the dice is the lowest is 1 and the maximum is 6. So this is what I'm trying to do in this program. So basically generating a dice. The minimum value is 1. The maximum value will be 6. So all we have to do is to show the dice one. So I'm gonna put dice 1 here. Dice 1 and dice 2. To do this, you can basically guess the number in here and minus 1 plus the minimum number. So you can complete it up to how much you want, or you can use the formula. You can also use this formula. So it is all up to you how you want to handle this situation. I don't use the formula that much, to be honest. I just keep it to myself that how I wanted to achieve, but technically you can use the formula as well. For example, when you want to create a dice between 50 and 100, a random number between 50 and 100, 100 minus 50, 50 plus 1, 51. So you always add plus 1. So this means it will generate in between 0 and 50 plus minimum, which is 50, then the maximum number will be 100. The same goes for our scenario. This one will generate a number between 0 and 5 because it starts from 0. Now adding 1, the maximum will be 6. The minimum will be, if this is 0, will be 1. So this means that the dice that I'm going to generate is in between 1 and 6. Let's try to run this thing to see the outcome. And as you can see, dice 1 is 4, dice 2 is 1. I can rerun this as many times as I like, and each time I run it, you will see that the dice change. The dice change, sorry, not dices, but the dice change. Dice is plural already. So each time you run it, you can also press F11 on your keyboard.
to run the program. Each time you will see different numbers. You see that was 4 and 2 before, now it's 6 and 2. And I'm going to run it again. And now I have different numbers. One of them is 5 and the other one is 6. Okay. This is the predefined functions. I already covered it. There are more exercises here. Look at them by next week. And if you have any questions, let me know. In the next one, I'm going to go into user-defined functions, which means I'm going to start from this chapter. So all of this up to the slide number 8, I already covered it. In the next week, we will continue with user-defined functions. Now, before I end up this lecture today, do you have any questions to me? I think we need to talk to each other a bit more now, since it's very easy to misunderstand each other on form messages. From what I understood here, that you think that I'm a very aggressive person, or I'm trying to put you down, or something, or I enjoy that you are not doing good in the midterm and I'm enjoying this experience. Let me assure you that I do not enjoy when you fail from a course. Okay, I do not enjoy it, and I don't get more money when you fail. I actually get upset because when you fail and you do not perform very well, I also take the responsibility, and I also tell myself that maybe we didn't do a good job for these people, and that's why they didn't learn. You understand that if you become successful, it's your success, but it's also my success because I have been lecturing you. Okay, so we are in the same ship. All I'm trying to do is to differentiate who is learning from who does not. Okay, because I'm worried about you. Every passing day, guys, finding a job outside in the world is becoming more and more difficult. Uh, there is a job vacancy, hundreds of people apply for it, but only one is going to get the job. And I'm sorry to tell you these bad news, but it's going to be worse after this pandemic because of a lot of people will apply for jobs, and uh, they will be more qualified than you are. Probably, if they are, of course, they will get the job before you. So the only thing you can do right now is to learn as much as you can in the university. So you basically gather this knowledge, and you can prove that you can put more efforts into these companies. Okay? Otherwise, they will never hire you. So this is not a high school anymore. It is your job. It's gonna be your job for the next 30 years. So whatever you learn here is gonna benefit you in the future. This is why I'm trying to differentiate who is learning from who is not. Not because I enjoy that you fail from a course, but because I really want you to learn before you move to the next stage of your career. Okay? So please, let's not misunderstand each other. And if we have any problems in the future, don't send me emails. Don't post forms aggressively. Don't talk to other people. But let's wait to meet face to face, like not face to face, but at least we can talk each other like this. And I'll be happy to give you the right to express your ideas here, talk. Okay? Now, before I end up this lecture for today, do you want to say anything?
Thank you, sir.
Okay. Is there anyone who is who wants to express themselves?
So,
Yes. Do you have something to say?
yes, sorry to take you back in respect of the quiz, the midterm that you gave us, of which you said a lot of people cheated. So I'll suggest that the time frame for the midterms, for the midterm exam, should be open for maybe about 30 minutes, so that every student will be online at the same time. They will start at the same time and end at the same time. So that those who attempted the question were able to share it with others who have not attempted.
Yes.
It's a very good idea, and I will actually do that. Thank you very much for your suggestion.
All right. So.
Yes, Prince, you want to talk? Yes, Prince, you raise your hand. Do you want to talk? Okay, he must have a problem or something. Okay, guys, I'm just gonna stop the lecture for today. We are way over 120 minutes almost. So this was a very long time. We have been doing the course for 2 hours now. I'm gonna stop here. Please announce it to your friends. They might not have come to this class today. Please tell them the decisions we have taken today. And if they want to express themselves, please tell them to come to these online sessions. This is where we should talk to each other. By communicating, we can solve these problems. Don't forget that. But that communication shouldn't be on emails, shouldn't be on the forms, because it's very easy to misunderstand each other. Because I have a problem with Moodle, it didn't open for me, for example. Someone assumed that I blocked them. If I wanted to block you, I wouldn't invite you to my Zoom. I can block you on Zoom right now if I want to. Why would I block you? You are a student of me. I don't want to block you. I want to encourage you. I want you to be successful. But it's very easy, as you can see, to misunderstand each other. Okay? So let's talk in these sessions when we have problems rather than sending each other mails. All right? I'll see you guys next week at the same time. Take care. Have a lovely week.
Thank you, sir. Thank you,
Bye.
sir.